Okay, so this is the study guide that was made by the other SIs, and I'm just going to be going over a few problems. And so the first one is telling you that you have a normal distribution with a mean of 75 and a standard deviation of 15. So if that were just a regular normal distribution, this is how it would be written. So the mean is 75 and your standard deviation is 15 because you always put the mean first and then the standard deviation second. But now A is telling you that you have a different type of distribution. It has that little X bar. So that means that you're dealing with the central limit theorem of a mean. And the way that you figure this out, it's similar to this one. The mean is still going to go here, and the mean is still going to be the same. So just as how this tells you that the mean is 75, your mean is still going to be 75. But to find a standard deviation for it, you take the old one and then you divide it by the square root of your n. And so this 15 came from the standard deviation, and your n, they tell you that you have 22 randomly selected people. So this 22 is going to go in the place of the n because that is your sample size. And now just putting that in the calculator, 15 divided by the square root of 22. And that, once worked out, this is going to be 3.198010. And now part B is telling you that they want to find a probability, which means that you can use GeoGebra or norm CDF in your calculator. And I'm going to be using the GeoGebra approach, and they want to find the probability that X is between 55 and 80 minutes. So they want it to be at least 55, but no more than 80. And since it's telling you that they want to find this probability for the group of 22, you're going to be using these numbers right here, this mean and this standard deviation. And my mean is 75, and my new standard deviation is 3.1980. And then since you want to find the probability that's in between 55 and 80, you just use the middle part. You put your numbers in and then press enter. And so your probability is going to be 0.941, just like that. And now part C is telling you to find the probability of a single randomly selected individual. So notice the difference. This was for a group of 22. This is just for one person. And so whenever you're dealing with one person, you're going to go back to this regular distribution right here. So since you're dealing with a different, so you're dealing with 1/5, while this probability was dealing with this. So now I'm just going to be plugging these numbers back into GeoGebra to find my probability. Okay, so my mean is still 75, but since I'm working with the other standard deviation of the parent's distribution, I'm going to be using these numbers right here, and I want to find the probability that it's made between 50 and 80. Press enter, and your probability is 0.5393, just like that. Okay, and then number 3 is telling you to suppose that you have a mean speed of 75 and then a standard deviation of 8. So I just put this into the normal distributions to sort of write it out. So this would be considered like the parent normal distribution for this problem. And then A is telling you to use the central limit theorem to find the probability that a randomly selected group of 15 has a mean speed that is slower than 65 miles per hour. So since you're not finding the probability of a single person, since you're finding the probability of a group of 15 and a mean speed, you're going to be using the central limit theorem for means. And that's why I'm having the X bar right here. And so you still keep your same mean as before. So the old one was 75. So the new one is still going to be 75, but you're going to have a new standard deviation. And that's going to be the old standard deviation divided by the square root of n. And so your old standard deviation was 8, so the 8 goes in place right there. And then your n, there is your sample size. They're telling you that your n is 15. So the 15 is going to replace the n. So your standard deviation is going to be 8 divided by the square root of 15. And after putting that into the calculator, I get that the new standard deviation is 2.06559. And now you want to find, now using these numbers right here, this is going to be your mean, 75 is your mean, and this 2 and onwards is going to be your standard deviation. So you want to use those numbers to find the probability that your mean speed is going to be less than 65. So I'm just going to be plugging these into GeoGebra. And I rounded the standard deviation because Desmos only goes to the 4th decimal place, but I put in the mean and the new standard deviation left tail, and I want the probability that it is less than 65. And so I would just put the 65 in, press the enter key, and you get that the probability is 0. Part B is asking you if the assumption that it's a normal distribution is necessary, and in order to know this, you have to look at your sample size. And if your sample size is greater than 30, then it is not necessary, but in this one you had a sample size of 15. And since you had that sample size of 15, then it's not smaller than 30. So yes, it is necessary for this problem. And now part 4 is telling you that you have an average horror movie runtime that's normally distributed with a mean of 95 and a standard deviation of 10. And then it's telling you that a researcher watched 12 movies and that became his sample size. So 12 is going to equal n, and since it's normally distributed, and since it's normally distributed, you have a mean of 95 and then again a standard deviation of 10. So, and now A is telling you that it wants the distribution for a sample mean. And so whenever you see this X bar right here, your mean is going to be the same thing. It's going to stay the same. So just as how 95 was your mean for the regular X distribution, it's going to be the same for your sample mean distribution. So the 95 went over here, and now it's going to go over here. And since it's a sample mean, the way that you get your standard deviation is you take the old standard deviation and then you divide it by the square root of your n. So my old standard deviation was 10, so 10 is going to go right here. And then n is your sample size. They tell you that there were 12 movies that were recorded, so 12 is going to go in place of the n. So your new standard deviation is going to be 10 divided by the square root of 12. Okay, and after working that out, I get that my new standard deviation for the sample mean is 2.8868 rounded. And now part B is wanting you to still work with those 12 movies, so still working with your sample size. And it wants you to find the probability that their average is between 87 and 110. So this is what's going on right here. And since it's working with your sample size, and since it's working with an average, you're going to be using these numbers right here in your calculator or in your GeoGebra. The 95 is going to go right there. My rounded standard deviation is going to be 2.8868, and I want it to be between 87 and 110. Press enter, and so my probability is going to be 0.9972. And now part C is telling you to find another probability, but it's telling you to find the probability for one randomly selected person. And notice how it's not telling you to find the probability of an average, just the probability of time. So since you're working with only one randomly selected person, you're going to be working with these numbers right here, the 95 as your mean and the 10 as your standard deviation. And since you want to find the probability that X is between 87 and 110, you are going to be using GeoGebra or calculator again. Okay, and so the mean is still 95. Switch back to the standard deviation of 10 and finding the probability that it's between 87 and 110. Press enter and I get that my probability is 0.7213. And now part D is telling you to find the distribution for sums. And whenever you have a sum, this is the distribution for it. It's going to be your mean times your n. That's going to be your new mean. And then your new standard deviation is going to be your standard deviation times the square root of n. So I'm working, originally it told me that there was a mean of 95. So 95 times 12 is going to be my new mean, and then my new standard deviation is going to be 10. Again, working with this, 10 times the square root of 12, which again is my sample size. And now I'm just going to reduce these. Okay, and now this number and this one, they are only reduced versions of these two equations right here. And now part E is telling you to find the probability that 12 randomly selected movies will have a total runtime. So since it's telling you that you're working with 12 movies, that's still taking your sample size into consideration. And then it's working with total. So total is the same thing as sum. So you're going to be using these numbers right here. So you want to find the probability that it is less than 1,100. And again, since you're working with the sum, you're going to be working with these numbers right here. And I want to find the probability that it is going to be less than 1,100. Press enter, and I get that my probability is going to be 0.1241. And now part 6 is telling you that you have a uniform distribution that's between 300 and 400. A is going to be the starting point, and then B is going to be the ending point. And then it's telling you that they want to find the probability that a randomly selected sumo wrestler weighs anywhere between 360 and 490 pounds. And if you want to solve this, if you want to turn the uniform distribution into a normal one, then that's when you're going to have to first find the mean and a standard deviation. And so to find the mean, it's going to be A plus B divided by 2. And then your standard deviation is going to be B minus A divided by the square root of 12. So your A is 300 and your B is 400. Okay, and when these are worked out, your mean is going to be 350, and your standard deviation is going to be 28.8675 rounded. I just put these in the calculator earlier. And so with that mean and that standard deviation, this is how I like to just write it. So I could just consider a sort of normal distribution since I have my mean and the standard deviation. But yeah, you need to first find your mean and your standard deviation before you can do this. And so now that I have a mean and a standard deviation, to find the probability that a randomly selected person, which is just one person, means that you're going to be using just the regular x. So the probability that x is between 360 and 490, and I'm just going to be finding that on GeoGebra. And after plugging that into GeoGebra, I get that my probability is 0.3645. And now part B is telling you that it wants to find the third quartile. And the quartiles, there's 3 of them. There's Q1, Q2, and Q3. They're all percentiles. So the first quartile would be the 25th, the second would be the 50th, and the third one is going to be the 75th. And since you only want to find the 75th percentile, I'm going to find this again on GeoGebra. So once the mean and the standard deviation for the original uniform distribution are put in the calculator right here, now I want to find the probability that, now I want to find the third quartile, and again that's 75% of the area, so you put 75 in this section right here, press enter, and you get that your third quartile is 369.